provide a counterexample to show the following statement is false. If an animal has wings, then it's a bird. Now to me, the obvious counterexample is the bat. The bat is a mammal, but it has wings. But there's numerous insects, of course, that you could also give as counterexamples here. We want to prove that the opposite angles of a cyclic quadrilateral are supplementary. Now, many of these proofs are based on the first theorem that we looked at in the course, which is the angle at center. So when we have a situation like this, if this angle is alpha, then this one is 2 alpha. So let's draw a circle, and here's the center, and let's draw a cyclic quadrilateral. Remember, that's with all 4 vertices touching the circumference of the circle. Now what you do is add in 2 radii, like so. Now, let this one be alpha. Then it follows that this angle here is 2 alpha. And you need to state that that's because of this theorem. You need to be very, very clear in what you're doing here. Now, this angle here would be 360, take away 2 alpha, and then using the same theorem again, this angle here is going to be half of this one, which is 180 take alpha, and then we can see that these opposite angles, alpha plus 180 minus alpha, equal 180. But as I say, you need to write down all of the steps very carefully and keep referring to the theorem that you're using. Now, we want to prove that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And remember, a rhombus, what distinguishes it from a parallelogram, is that all the sides are the same length. So we have OPQR here as a parallelogram. So this vector here would be B, and this one would be A. And if we look at the diagonals, OQ is going to be A plus B, and PR is backwards along A, forwards along B, so we can write that as B minus A. Now, if they're perpendicular, then OQ dotted with PR would be equal to 0. So A plus B dotted with B minus A would be equal to 0. So that gives me A dot B minus A dot A plus B dot B minus B dot A is equal to 0. Now A dot B is equal to B dot A, so those cancel. A dot A is just A squared, B dot B is B squared, and that gives us A squared equals B squared. And remember that A squared means the modulus of A squared. So what that's saying is that the modulus of A is equal to the modulus of B. And the modulus of A is this length, the modulus of B is this length, and therefore we're done.